that is my screen is visible to everyone, and is my voice is clear to everyone. Okay, so thank you so much. Once again, it's been a pleasure to be here. And today we will be talking about reporting statistical results. So I have divided this session into three main parts. So firstly, we will discuss simple rules for effective statistical practice. Then we discuss some guidelines that can be used to present statistical results. And finally, we will discuss some statistical issues in non-statistical research. So let's get started with a very beautiful quote from a famous statistician. His name is John Tukey. And once he said that the best thing about being a statistician is that you get a chance to play in everyone's courtyard. And this is exactly what I am experiencing since last 10 years or so. So whenever I meet someone either from academia or from industry and we talk about research, so they usually come up with a question that I have data, I want to apply this data for a specific purpose. So what kind of technique I can apply on this data? So this is exactly where the trap exists for non-statistical audience. So here I would like to explain this thing a little bit in more detail, that when we think about statistics, so we should not only think it as a science of data analysis. We should think it as a science for solving problems. So for example, we have experiments generate data, and data are used to answer the questions. But those users who are inexperienced in statistics, they think probably they should think data first, and they try to think to apply a statistical tool on that specific data, irrespective of thinking about the goal or the research questions. So here, the main point which I want to highlight here, the very first goal when we think about effective statistical practices, we have to think about statistical method in a way which answers specific scientific questions. So this is the very first rule when we think about stats. We should not think it as a data analysis. We should think this as a kind of more than that, a science which is used to learn from data. The second thing, when we think about stats, it is basically one of the main goals of statistics is to deal with variability. So variability could be good for us. For instance, if we want to explain the variation in response, so we would love to have predictors that have some variability. For example, if we want to know whether the smoking is associated with cancer, then we should expect that the smoking habit should be variable instead of being a constant smoking habit. Similarly, if we want to explain or we want to know whether there is a relationship between a genetic disease, genes and disease, so in that particular situation, we definitely want a variation in genes as well. But sometimes variations could be annoying. For example, we toss a coin in the same situations, same way, but we get the different results. Similarly, if we want to run a model and we have some predictors and there are still those variables which we cannot consider in our study, could not be studied. So in that particular situation, we usually come up with two kinds of variabilities. One is called signals, and these are those variabilities which we have interest in. And the other variabilities which are not that much relevant in our study, or maybe we can't explain them based on the data, are called noise. So these two things we should keep in our mind, which is the second rule for being a effective practical statisticians. So when we think about statistics as a problem-solving tool, when we think about the variability and probability theory to explain the variability in the data, for example, then we try to think how to collect the data. And in that particular thing, sometimes it happens that people come up to us, statisticians, to explain or to ask sometimes that they are going to analyze a specific data and they are stuck on a specific thing, then how can they solve this problem? So if you are, for example, analyzing some kind of data, then you should think all those things from the very beginning instead of analyzing and then dealing with the statistician. So I'm just going to quote a very famous statistician's words that if you do something like that, then to consult the statistician after an experiment is finished is often merely to ask him to conduct a postmortem examination. So he can perhaps say what the experiment died of, but he cannot make your experiment once again alive. So you should keep this third rule in your mind when you are going to apply a statistical tool effectively. So the fourth rule is when we think about data, we should always think about quality of data as well. So what does this mean? This means that we have different, for example, variables, and we should have to think about how can we clean the data, what variables we have in the data, what are the scales of those variables, whether those variables are nominal scale, whether those variables are on ordinal scale, how much missing values we have in the data. And then we also have to think that what kind of the measurement we are going to use in our data. For example, when we're going to collect the data, say age, so we can think age in a different ways. We can think maybe age in years. So in that situation, we probably would have to collect the data something like 0, 1, 2, 3, and so on. Sometimes we may think age as an ordinal variable within a specific age group. For example, 0 to 5, then so on, 5 to 10, and so on and so forth. So these all things we should keep in our mind when we are going to conduct the research. And if we want to be an effective researcher in terms of statistics, then we have to think all these things in our mind. And then there is another thing which comes under the data quality of a specific study, that is missing value or incomplete data. So missing value may occur for different reasons. Missing value could be something like, which is called completely random. So in that situation, you can't do anything. There are different ways of dealing with that values. Sometimes you can get missing value non-randomly. Sometimes there's a respondent who is not going to answer a specific question. So you should keep all these things in your mind when you are going to conduct the research, and you should be very much careful about the quality of the of your data. So always try to understand as much as you can how these data arrived, right? And then after, for example, you got the data, you have cleaned the data, you have no missing values, you don't have any missing values, for example, in the data now. So then you have to format or transform the data in a form which can be useful for you. And that particular thing is known as wrangling, data wrangling. So after getting data wrangling, then you have to explore the data. So in exploration, there could be different ways. They could be, it all depends on your research questions. What kind of questions you have in your mind? What are the problem you're going to solve? For example, if you have one particular variable that you want to explore, then you have to think whether that variable is on the ordinal scale, nominal scale, or ratio or interval. Then accordingly, you have to pick or select a specific suitable chart or graph. And if, for example, you have two variables or more than two variables, then probably the interest is to explore the relationship between those variables. So these all things you should keep in your mind when you're going to collect the data. So this is usually known here as the fourth rule of being an effective researcher in terms of statistics. So after, for example, you have collected the data, you have cleaned the data, you have explored the data, and now you want to apply a specific technique in order to answer your question. So when you are going to do that, then you do not think that you are going to just doing a kind of computations, because nowadays softwares are available. You will give the data to those softwares, they will give you something, some kind of answers and things. But the thing is, whether those answers are useful, how can you interpret them, whether those are related to your research questions, yes or no. So you have to be very much selective here as well. And then you have to think whether those questions are in fact asked in a way or answered in a way which actually related to the scientific context of your study, right? And the key principle to statistical analysis is to bring analytical methods into close correspondence with scientific questions, right? And then when you're doing all these things, you should keep things very simple. So simple means there could be a method which can solve your particular question, and that method is quite simple. And there is another method which is relatively complex, and that is giving the similar answer. So you should always try to pick the method which is simple, which is easy to understand, and then you should start build on it. I remember a case when I was at Pakistan a few years ago, and there was a Viva of MPhil students was going on, and I was a kind of internal examiner. So the person at that time was trying to find a specific, fitting a specific model. They were trying to fit a specific regression model. And in that specific situation, they have a response variable which was quantitative. Particularly, if I remember correctly, it was on the continuous scale. So what that student did, she tried to convert that particular variable in the form of binary variable, binary outcomes, in order to fit the logistic regression. And it doesn't make any sense, right? So you should always keep the things in your mind that if you are going to conduct a specific analysis and that analysis is giving the answer to your question and that analysis is really simple, it doesn't mean that it is not a good analysis. So you should keep these things in your mind. So the seventh, when sometimes it happens that we are going to conduct a simple analysis, but sometimes things are complex. For example, you're going to analyze social sciences data, then there would be a multiple other factors that you can't control, and sometimes you can't even fit a simple model to those kind of data sets. So in that situation, definitely you have to think about some advanced techniques. So the seventh rule regarding effective statistical practice is that you have to assess the variability. As I've already told that the one main goal of statistics is to deal with the variability. And usually it is done through using standard errors of estimates or sometimes confidence interval. So when you're going to report your analysis, you're going to report your estimates, you should include these two things as well in order to give a holistic view of the specific analysis. And then there is another important thing that you should keep in your mind when you're going to analyze the thing is that assumptions, because sometimes it happens that those users who are inexperienced in statistics, who are not have enough experience of using statistical techniques, what they usually do, they hire from somewhere or maybe sometimes from their supervisors that for this particular analysis, for this particular data set, you should fit, for example, say regression analysis. And they just try to come up with some findings irrespective of thinking about the assumptions. So you should always keep these things in your mind. If you're going to apply a specific test, if you're going to apply a specific model, first of all, you have to test the assumptions. And usually those assumptions are whether the data, your response is on the ordinal scale or is a continuous variable, and sometimes linearity matters, sometimes normality matters. So you have to check all those things. So these are important things when we conduct research. And then the ninth rule is sometimes we have to, in fact, most of the times, we have to come up with the findings which are replicable. Usually researchers do, and they think that if they have a result which are non-significant, which are not for example, giving any kind of significance, then they try to, they don't report those results. They try to hide them and try to manipulate the data, and then they try to make their analysis in a way that the variable which are of their interest, they become significant. So this is not a right way to do the things. So irrespective whether your variables or whether your analysis is giving you significant results or non-significant results, try to report them and try to explain them. And then you'll get the idea that why those results are getting not significant, why you are getting some non-significant things. And these kind of things usually known in technical language data snooping or p-hacking. So in many contexts, sometimes it is not easy to replicate your results. By replication means that if, for example, you are applying a statistical model or things for a specific data, and you have come up with some findings, and if, for example, some other one is going to apply the similar analysis, then they should come up with the similar findings, similar results. But sometimes it is not applicable that because if you have a large number of experiments, such as multi-central controlled trials, you can't replicate every time. So in order to get the replication kind of equivalence here, usually the term is used reproducible research. So reproducible research is really important in science. So what happens when you are going to conduct a specific analysis and you're going to publish that specific report, maybe in a journal or in any press, press article. So sometimes the journals ask you to include your codes, to include all the workings which are relevant to your work. So these kind of things usually done to make more transparent research. This is called reproducibility. So given the same data of data set together with a complete description of analysis, it should be possible to reproduce the tables, figures, and statistical inferences. So these are usually the 10 simple rules which you can think of when you are going to conduct an effective statistical practice in your research. So if you have any question until now, what we have discussed, so please ask. And after that, I will move to the next thing, which is related to presenting statistical results. So we have discussed 10 things. If you have any questions so far, so I think so I'll give 3 to 5 minutes to discuss these things, and then we move to the next topic.
Thank you so much, Dishan. We have a question here in the chat. If you could please open the meeting chat. From the Alexandria University in Egypt, somebody has asked that if I have a large data set, but it is not normally distributed even after transformation, should I use non-parametric analysis instead of ANOVA, or should the large data set compensate the normality? Sorry.
Well, it all depends. So if we talk about parametric and non-parametric things, so usually parametric are, I'm talking about broadly, in broad terms, that if the distribution is normal, if you have a response and distribution is normal, then usually we try to verse parametric test, provided that the variable is also, is a continuous one and quantitative as well, or discrete. But if you have, say, small data set and its distribution is not normal, then you move towards non-parametric side of things. But here you have mentioned that you have a large data set. But the thing is, whether that large data set is on the ordinal scale or the ratio scale, on what scale, then you can decide. But generally speaking, for a large, if you have a large data set, I don't know what do you mean by large, whether you have 100 observation, 1,000 observation, because you have to, mention here, what do you mean by here large? But usually when we have large or thousands of observations, sometimes the distributions approaches, towards normal by using the central limit theorem, right? irrespective of the nature of the distribution, if you have a very large data set, then it will approximately approaches to normal. And in that case, you can think of parametric approaches. Usually.
Thank you so
But
much.
yeah, overall, you have to think about pros and cons of all things. What are your objective and things like that.
So there are more than one ways of catering to this issue.
Yes, but it all depends on the purpose of your research or your research question. In what way you are going to analyze your data. That's why I said, don't think about the technique, just think about the research question, what kind of problem you want to solve. You shouldn't think statistics as a data analysis tool only. You should think a kind of subject which will help you to solve the problem.
Okay, so Professor Hanan from Alexandria University, Egypt, has elaborated on his question. He's saying that it's nominal scale and it is around 600 readings for one biological variable. So that's, in this capacity, he means to say that he has a large data set.
Okay, but still, I mean, nominal scale, how much categories? 1, 2, 3. I mean, by the virtue of central limit theorem, which approaches towards normality. So I think so you probably can apply parametric techniques, but it all depends on your research question and the interest of your study.
Okay, thank you so much. So we have a few requests that say that if you could please talk about rule number 8 and rule number 9 once again. Very briefly, you can cover that.
So rule number 8 is check your assumptions. Okay. So for example, when we talk about assumptions, it means we are going to talk about a specific method first. Say we have a data, we want to answer a specific question. In order to do that, we have explored our data through a specific descriptive analysis, right? And now we want to answer our question, say, based on ANOVA. So in ANOVA, what are the assumptions? So the first thing, your response should be categorical. Second thing, your sample should be random, independent, or indically distributed, should be normal, or maybe non-normal, because for non-normality, we have critical values test, which is an alternative to the parametric ANOVA. Then we have to think, for example, about if we are going to apply regression model based on our research question, it is a suitable thing. So in that context, we have to think what are our response, whether it's continuous or not. Then we should have at least one quantitative variable. Then we should have the relationship between response and each quantitative variable should be a linear, right? And there should not be too much multilinearity. So these are the things that we should consider, right? So similarly, if we are going to test the averages, for example, we have two data sets, we want to check whether the average of the first data set and the second data set, whether there is a statistically they are significant or not. Then we have to probably think about the t-test. And then question comes whether those samples are independent or dependent, right? So these all things we have to consider and we have to explain and we have to check what kind of technique we are going to use, right? And then
thank you so much.
Sorry, it was 9th or 10th?
It was 9th and rule number 8 and rule number 9.
Rule number 9. Okay, so the 9 is, for example, you have analyzed something. You have a data, you have analyzed it, and then you come up with some findings and discussion, then you come up with a theory that if this happens, then this happens based on this research, right? Then this should be replicable. If, for example, I'm applying the similar kind of analysis in a different data set, or someone else is applying in the similar context, then the actual findings or numbers may be different, but the overall conclusion should be similar, right? but sometimes it is not easy to replicate each and everything. So in that context, we have to think about reproducibility. So what happens when we submit our paper in a good journal? They ask us to submit our working, our codes, our analysis. So we have to submit all those things. And why is this important? Because if someone else want to replicate and want to check whether the result that we have mentioned in our paper, are they really those results which we got from that analysis or not? So to verify those things, they usually do this reproducibility thing. Any other question?
No, we don't have any other question. There is another case scenario which Arsalan from Thailand has posted in the chat. He's asking if you could please provide the possible experimental design for a case that he has mentioned in the chat. I think we can take this after the next section, after the next segment of your session. So you can probably start that, and Arsalan will try to take your question. If not, I think Dr. Zishan can separately answer this, because this is, your question pertaining to your study. So we can take it up after the remaining part of his session.
All right, thank you so much. So now we're going to move towards the second section of this presentation, and that is related to how to present your results. So here, I'm not going to explain each and every point in a specific context. Okay, so these are the general guidelines, and you can adjust them according to your area of interest. The first thing is the following are general tips to ensure good presentation of statistical results. And the very first thing that you have to think about the full picture, right? So when you're going to present your result, you should not pick and then try to present a specific portion of your results, right? Instead, what you need to do, you have to write about statistics as a whole, right? Do not just say, for example, if there is a change, so do not just say that there was a change, for example, fall in prime. Always also say either what it fell from or what it fell to, right? The second thing is, do not claim too much. So what does this mean? Sometimes, usually students, most of the times, think that they have data, they know about the theory, and this mostly happens in social sciences, and they come up to us, I mean, or their supervisor, and they say that, okay, I have a data, I want to prove or disprove this theory. But you can't prove or disprove any theory based on just one research. So that's why avoid to use these extreme languages in your academic writing. Instead of, you can use indicate or suggest. So for example, you can use a 27% fall in knife homicides suggest the initiative may be contributing to a decrease, right? So just avoid these words. Then, if there are things in the data that you want to compare, then the comparison should be meaningful. So what does this mean? This means if you are going to compare the two figures, then those should be from the identical time period. So for example, if you're going to compare the crime from September to December from 2012, and you are comparing this for the next year, 2013, then you should consider the same time period, September to December 2013. And likewise, for example, if we are going to just explain a seasonal variation of a specific variable, then you have to pick the same month. And the same goes for if you are studying weeks or days or whatever, the holidays kind of thing. You should keep these things in your mind to avoid seasonal misinterpretations. And sometimes it happens that you are going to compare data sets from one locality to another locality. And in that, you should also be very much careful what kind of variable you're going to compare. For example, you're going to compare, say, police forces, and from one region to another region. So you probably have to think whether is it comparable or not, because some data sets, as they vary in terms of population, and geographical size or composition, maybe comparison is not meaningful and doesn't make sense. You can compare, but there is no point of compare in terms of explaining those findings, right? Uh, so this is another point that you, as a researcher, should keep in your mind when you're going to represent or present your statistical results. Another thing is be clear about data source. If you're going to report data from a secondary source, you have to be very much clear from which source, right? And you should also give web links or references, or the more information is the best, the more you have. And then beware of small numbers, because small numbers are really, really, really important things. Right? They can, I mean, those small numbers are sometimes large numbers as well, because those are outliers. Those numbers may affect your results. So for example, if you're going to report, say, 11 homicides, which is a very small number in terms of homicides in a specific year, and those homicides decreased from 2011 to 2012 from the previous year, right? Then you have to be careful about that. You have to report that exact number instead of mentioning the percentage. Because if you mention, I mean, the 1 over 10 divided is equals to 1 over 100 is equals to, I mean, 10 over 100. And so you should be careful about, reporting the relative quantities when you have small numbers. So if you must use percentages, always include the actual numbers so that research do not overinterpret accuracy. For example, if you are going to report 12% homicide, then you have to also mention the absolute number as well. For small numbers, also consider using simple proportions. Sometimes it's easier to write a fifth instead of writing 20%. Right? So these things are useful in terms of reporting your results in academic writing. And then you have to be clear about the limitation or quality issues affecting the data. Explain the sample size if you're going to use it, response rate, what was the response rate in your study, whether the sample is representative, what kind of technique you have used, right? So these explanations definitely comes in the methods section in detail, but here you have to just mention what number, how many sample size, and things like that. So not any change in data collection method if you have done that. So indicate whether results are statistically significant. So here the significant term is important because we are interested to know whether the result is significant or not. So use footnotes or not to editors for technical details. And in addition to that, keep the things simple, right? Then first try to explain the general findings of your results, then move towards specific findings. For example, if you have put a specific graph, just explain the general outlook if it is relevant to your research question or your study. And then pick those points where the graph is giving a more significant, trend maybe, or if there is maximum point in the graph or the minimum point, these kind of things. Avoid extreme or qualitative words. For example, extremely, I mean, if you, for example, you have a one specific variable and that variable is decreased from the previous year, and so do not use something like that. A specific, I mean, the prime rate is extremely decreased from the previous year or remarkably decreased. So these are the extreme languages, and we try to avoid these kind of things in academic writing because these are just a subjective approach, right? Similarly, there are some technical words that we should avoid when we are going to report statistical results. For example, significant. So significant in English could be a different than what it is meant in statistics, right? So try to avoid these kind of words in your academic writing unless you are talking about in the context of statistics, right? And same goes for averages. So averages, there are multiple kind of averages. Mean is average, median is average, what is average? So what kind of average you're going to talk about? So you have to be very much specific about that. Then lead process of data collection to method section. You do not need to explain these things in the result. So in result, you have to just describe the result. No discussion, no methods, section things here. Do not include any discussion, and always use past tense in describing your results. Do not repeat the same information in more than one format. So usually we would have three kind of formats in statistical reporting. One would be text. The second could be tables. Third could be graph. It is you who have to choose or pick which one is suitable. But you have to think whether you are going to pick graph or table, but definitely you have to include text, right? And think these are the complement to each other, right? It is not a good practice to you. For example, you are going to explain a specific variable in counts in table, and then you're also explaining the same thing in graph. So most of the times, if you are interested in specific values, specific percentages, then it's a good idea to write them in the form of graphs and presenting them in the graph. But if your interest is in trend, and you are not caring more about the specific numbers, specific values, then probably you can think in terms of graphs or charts, right? And then again, when you are going to including these things, you should add the titles of them, captions, explaining what those colors if you have used in your graphs mean, what kind of things a specific color is explaining, what is the axis. You have to label all those things, right? And then again, you have to think what kind of graph you're going to use. So for example, if you have a continuous variable, then probably you want to use, say, a histogram in order to find out the trend or the distribution of the specific variable. But that specific graph will not tell you about the outliers. Then in addition to that, probably you have to include the box plot, right? And similarly, if you have a qualitative variable, then maybe you can think how many categories that variable has, right? If less categories, probably you can think of, say, pie chart or maybe bar chart. If more category, then you have to think alternative things, right? So all those questions you should keep in your mind when you're going to present, right? So everything that you are going to add in your section, in your results section, that should be related to your question, your main question. It should not dilute the main focus. It should, I mean, if, for example, you have 5, 10 variables, it is not necessary to add the graph for each variable. Probably the more important thing is how those variables are related to each other, right? So just always think about your question and just try to solve that problem. In order to do that, what kind of method, whether in the form of graphs or charts, or what kind of charts you have to include in your uh, result sections, right? So these are the things that you should keep in your mind. But if you have any specific question about this particular section, please let me know. And then we will move towards the next section. Any question about reporting results? One more thing probably which I haven't added here, that is related to the style of reporting your results. So for example, if you are going to use APA style in your report, then you have to write your results in an APA format, and you can easily find this online by Googling that. And there are many other references style that have those specific formats to report the results, statistical results. Please be consistent throughout your report, right? So probably any question? Okay, so there's a question, sir. Sometimes you find other patterns that are not directly answering your question, but they are relevant to research area as whole. Do we need? Well, I think so. The main thing here comes what kind of audience you are going to present your findings. But I will prefer to be very much focused towards my the main question in order to describing
Excuse
this
me,
section.
Dr. Zishan, I'm sorry to interrupt you, but there is a box that's appearing on your slide and we cannot see the graph.
No, sorry, there's no graph. Now, is it okay?
Yeah, now it's fine. Now we can read the text. Thank you so much.
Okay, so I was saying that whether we should, you should report only those things in result section which are relevant to your, main question. But in discussion section, probably you can give the hint, you can discuss their the limitations even, and you can also discuss there that why those results that you get in the result sections are behaving the way they are behaving there, and how they are relevant to the previous studies, how they are different from the previous studies. Probably the result section is not a good section to present those kind of things, but maybe in discussion you can discuss if they are relevant to your area as a whole. So the second question probably I have, in social science research, we include those as well, specifically in future recommendation. Yeah, you can definitely include that in future recommendation as well. Thanks. Okay, yeah. So any other question regarding these reporting statistical results section? Okay, so now we are going to discuss briefly about what kind of statistical issues that a non-statistical researcher may face, right? And just try to be a reviewer yourself to your work, try to criticize your own work, and that's how you will improve the quality of your work as well. So here, these are the questions probably which you can think when you have a draft your first draft or second or third, maybe the final draft, and then you are going to review your report or dissertation or whatever the section you're going to review. So you can ask these questions to yourself. Is there sufficient detail to review the statistical aspect? So what does this mean? It means the sample size that you have mentioned or the effect size you have mentioned, whether you have justified that or you have just mentioned it, right? How have you calculated those size? How have you come up with those numbers, right? Have they presented enough information to verify their calculations? Sometimes these kind of informations you can add in appendix if you think those things are breaking the flow of your report or your arguments, right? Are the methods detailed enough to replicate results if data were available? Is it clear how results were derived, including test model, covariates, and assumptions, so all those things that we have already discussed in the previous actions. So you have to just ask those questions to yourself, right? And then you can also ask something like, are there any common statistical issues? So sometimes p-values, there are some journals, mostly in psychology, which usually don't prefer to report p-values. So if you, for example, going to submit your report or maybe your paper in a specific journal, so be careful about these kind of issues. You have to check the guidelines from the journal's web page and check whether they are allowing you to report the p-values or not. And if they are allowing you, whether you have included a lot of p-values, and if yes, why? If not, why have you not included those p-values? And whenever you're going to include the p-value, try to report the exact p-value instead of writing p less than equal to 0.05. Sometimes it doesn't make any sense, right? So try to write exact p-value in your report. Are there any hierarchical data structures? And if so, as the analysis taken this into account. For example, sometimes it happens that you have a specific variable, then it has categories, then those variables have further subcategories. So whether have you considered all those things when you were conducting the analysis? If not, then how to, you can update your results and how you can maybe, defend your result, what you have already done. Does that analysis make sense or not? So you have to think all those things. So have continuous variables been categorized? Have trends been ignored? And sometimes it makes sense, sometimes it doesn't make sense. For example, if you have, say, a very large number of variables and it has a very large range. And in that situation, we usually try to categorize continuous variables in groups. It all depends. It all depends upon your research question, about your aim, what you actually want to achieve at the end of the day, right? So you have to think all those things. Then is the presentation of results appropriate? So here again, if you are going to select your, the findings in your report, then what are the variables that you want to report and what should be reported? I have seen both extremes when I usually mark papers or maybe dissertations, sometimes, assessments. So what usually one extreme is students usually add everything what they have done in analysis, each and every table, graph, and things, but they don't interpret the things. And in doing so, the main focus of your, research is diluted somewhere. So you should be very much careful. Another extreme, they don't add much, but they explain a lot of things, a lot of interpretations, but those numbers or those, symbols have not been reported in the form of results or graphs. So this is another extreme. So you should be very much careful. You should not be in either of the extremes, right? You should report only those findings which are relevant to your research questions, which will answer your research questions and which are relevant the study what you want to conduct, right? So do main results focus on the main research questions or deviate the secondary subgroups questions? Sometimes it happens that you include a lot of, graphs or graphs, for example, you have 10, 15 variable, and for each variable you have included a pie chart or bar chart or something like that if they are categorical. So doing so doesn't, make sense sometimes because those are not directly relevant to what you actually set in your introduction section, for example, as an aim, right? So you have to think about that. Are results presented without estimates, just p-values? Sometimes researchers, particularly non-statistical researchers, they usually add p-values and that's it if they are going to test. But this is not the right, way of doing things. So you have to add the estimates as well. Confidence interval is a better way as an alternative to reporting p-values. So you can probably replace them as well. But sometimes journal demands you to include both p-values or confidence intervals. So it all depends where you're going to present your work. So you should keep and consider all those things in your mind when you're going to report your results and when you're going to review your results in the results section. Our estimates presents without confidence intervals are standard errors alone used. So usually it's a good practice to include both standard errors and confidence intervals instead of including just one thing. So other 3 points that you should keep in your mind when you're going to, reviewing your work is, are limitations of observational studies correctly acknowledged if you're conducting observational studies? Are results over extrapolates beyond the data range to unrepresented population? So just, you should think if you're going to say forecast something or predict something, then those predictions should make sense. For example, if you have, say, regression analysis, so you can always predict within the range of the explanatory variables. right? On the other hand, sometimes you can forecast in time series analysis, maybe sometimes beyond the range of your predictors. So you have to think all those things in your mind when you are going to report your results or review your results. Is there appropriate consideration of the impact of incomplete or missing data? This is another important topic. So if, for example, 5 to 10% observations are missing, then sometimes it's not that much big problem. But if more than that, then that's definitely a problem because you'll get the biased results. And if those those missing observations are in your main variables, then definitely you probably get the results which may give you dubious, inferences. So you should be careful about that. Whether you are going to exclude all the missing values from your data. If you're going to do that, then there should be a rationale behind that. If you are not going to do that, then you have to think how can you deal with the missing values, and there are different ways of dealing with imputations, and there are many other ways. And then you have to classify what kind of missing value you have in the data, what kind of incomplete data you have in your data, right? So you have to think all those things, and then you will get the actual, the idea that how to think statistically about your results, right? So these are, I mean, all the sections that I wanted to talk about. But if you have any questions, please let me know. Otherwise, this is everything from my side.
Thank you so much, Dr. Zishan. This was really in detail. I welcome any questions. If the participants have any questions, please post them in the comment box. In the meanwhile, I've launched the session reflection. Please rate the session. So Zishan, I think you have answered all the questions really well. Okay. We have a question. Violetta, if you could please paste it once again in the chat. Okay. Violetta asks us that many times in papers you see results reported in different formats to show detail and more general trends, but you say that it's not a good approach. So can you please elaborate why shouldn't researchers do that?
In different formats to show details and more general trends. But you say this is not. So, so my point of saying this was that you have to be consistent, right? Sometimes it depends what kind of audience you are going to present that result, right? So for example, if you're going to present dashboard, then probably for the same type of variables, it's not a good idea to just, for example, you have a categorical variable, it's not a good idea just to plot all pie charts, right? But on the other hand, if, for example, you are going to present that in some academic setting or maybe some other similar kind of thing, then you have to be consistent. Consistency is a good. That's why I was saying consistency is important. But if you think you have, for example, plotted, just say 3 or 4 different type of graphs, and those are not breaking the coherence of your report, those are not diverting the attention of the reader, then probably it would be okay. But sometimes if you are adding too much different things for different, similar kind of variables, then probably sometimes reader may not get your actual point. But this is what I think. So
thank you so much. I think that what's most reasonable is that as long as you have a logical explanation of what you're doing and why you're doing, and if it is complementing your research objectives and answering the research questions, and you're not using a specific format just for the sake of experimentation and just for the sake of the variety, then I think it's all good. And I'm sure as researchers, when we even come up with a variety of formats, we do keep that in mind, that it has to complement our research objectives and questions. So thank you so much, Zishan, for taking all questions and for such an insightful session. I don't know what happens, but your slides get, they get some empty text box. I don't know if this
maybe,
is a,
yeah, maybe those windows, question windows are, yeah, now it's okay.
yeah. All right. Yeah, now it's fine. So thank you so much, Zishan. We'll share the session poll results with you in a separate email. And thank you all participants for joining us today. And we hope to see you again in our next webinar.
Thank you so
Khuda Hafiz,
much.
everyone.
Okay, goodbye.